Yeah, hello everybody, thank you for tuning in. Today we are going to talk about the possibility to create an emergency ventilator for patients especially suffering from COVID-19. And well, the first question is, what kind of ventilation do we need for these kind of patients? And I printed out this diagram, and I think this diagram shows it quite well. So here we got 0 pressure level. And the specialty is that we already have to start at a certain pressure. So it should never be the same as the surrounding. It should always be a little bit higher because the lung tends to glue together. So the so-called alveoles will glue together. So we need a minimum pressure, which is always a little bit elevated to keep these open. So then we will rise up to the top level. So we press the air into the lungs, but it's not a volumetric pressure we are putting in. It's a pressure which lets the lung expand by itself. Then we hold it for a while and then we lower the pressure again so the air will flow out of the patient. So what you can see on the internet at the moment is a lot of devices which are created, which are using these devices, and they are mechanically pressed so the air should flow into the patient. The problem here is you never know what pressure level you will achieve. So usually you will start at 0, so you will not have this offset. And depending on how fast you press it, you will have a pressure level which you can never exactly tell. So there's a security valve here which would open at 60 centimeter hydrostatic pressure, but this could already be a lot. Especially these bags are not made for 24/7 operation, so if you're pressing them, you depend on the ability of the bag to open himself again. So if you would not do that, you would probably not notice, and the patient would not get air anymore. So that's maybe not the best idea. Just as an example, I found a lot of them on the internet. That's such a kind of device which is proposed here. But as I said, I think that's not yet exactly what we should have. So what do we need? We need a device which is industrially reliable. So the things we are talking about will not be machines which are medically certified and so on. They are for emergencies. They are for a patient who would not get a classical ventilation machine anymore and who would have to die. So in this case, we need a machine which is as reliable as possible and which is easy and cheap to manufacture. And especially it has to take care of these pressure curves, because it doesn't help us at all if we have some kind of flow but it harms the patient more than it would cure him. So I'm having this water bucket more or less here, and if we again take a look at this curve, here we are at 0 centimeter hydrostatic pressure, here we are at 8, and here we are at 28. So what we would need now is a device which can bring this pressure to the patient, and we will use it. So if you've been swimming in the sea or in a public bath, the deeper you dive, the more you feel the pressure, and that's what we can use now. So I got a pressure sensor here with a small pipe here, and you can look on the screen here. The more I put him down though, the higher the pressure gets here. So that's the pressure we need. If you look at the scale here, we are at 30 centimeter hydrostatic pressure here, and that's exactly what we need. If we go out again, if we go in again. Well, and that's already more or less the solution to the problem we have. So we need a device which can oscillate between these two levels. And that's exactly what we're gonna do. So I'm bringing up the device now. So that's the machine we need. We have an arm. This arm is connected to a pneumatic cylinder. We can choose the level of oscillation, so we can choose how much difference in pressure we want to have. There's an electronic device where you can set the inspiration and the expiration time. In case you're interested, there's a very long video on this machine explaining everything in detail, also with English subtitles, so feel free to watch that. But what I'm going to do now is I will prepare that. I will put this bucket under the arm, and then we will have a look at the pressure curve and see how that works. Okay, so everything's set up now. The bucket is under the arm, and you will see how the arm oscillates between the roughly 28 centimeters and the roughly 8 centimeters. And to show you a little bit the effect, I created what I call an artificial lung. So that's a plastic bag with some weight on it. And the behavior is quite similar to what our lung has. So if there's no pressure, the air automatically flows out. If you put pressure on your lung, the air will flow into your lung. So that's roughly what will happen here. And you can take a look about the effects. Again, we can look at the curve here and see what happens. So I put pressure in the air system now, so you will see the bubbles come out. The lung is filled up, and now we will start it and work it automatically. Yeah. And very nicely you can see how the lung fills itself with air, the air flows out again. And also if you look here, the curves you can see here are quite similar to what we had on the diagram here. So if I just put it here, you will see that's quite similar. Quite easily you can set everything here, so you can set different timings, you can set the speed of the cylinder. So and if you listen to the noise of the machine is not very loud, so it's quite silent. And if you think about all that, you could also put it in a housing. So just switch it off for a second. So you could put all that in a housing, because the air flowing out might be contaminated with a virus. So either you put some kind of filter in here, or you put everything in a housing and make sure that there's a filter for the air afterwards. So that's quite a good solution, and if you take some minutes and tune the curves, you get to a perfect result for your patient. So you don't need the station, that's for demonstration only. It's enough to have this one. And I can assure you, this can be manufactured at a really cheap price. That's what I found out. Yeah, this is one solution. Some people might now say, well, this arm and all these moving parts, isn't there something which is even more easily to do? Yes, it is. So you may lose some abilities to control the curves, but the effect will be exactly the same. And that's what I'm going to show you in a second. Okay, so here we go. This is another construction which more or less does the same. So you see these tubes, the tubes are inserted to a certain depth. I can move them if I want to. And what you can see on the rear side, if I just turn that around a little bit, you see how there's a valve. And with the valve we can switch what kind of tube we will use to generate our pressure level. As I said, you cannot set the curve as perfectly as you can do it with the other system, but well, I talked to a medic who's specialist in this area, and he said, well, that also would do the purpose. Okay, I'll switch on the pressure, and we'll see in a second what will happen. So just start the timer here, and again, take a look. You see the different levels in the pressure, so I will actually lower it a little bit. So you see the pressure levels, you see how the lung is working, and again you would have a positive result. And the patient suffering from corona or any other disease which might not get one of the ventilation units could be saved by such a machine. So this is some possibilities which I created. So I'm an engineer and I'm not a medic, but I had the first machine tested in a hospital, and the feedback I got was very, very positive. And the good thing is, at the moment we don't need them yet, because our health system has enough beds, but who knows if somewhere in the world this could be necessary, that could be a solution. In case you say, well, I need that urgently, after I made the construction and I was looking for the prototypes, I found a company who manufactured these, and they would also have the capacity to produce hundreds or thousands of these just in case. So if you're interested, look into the description below this video, and I will put an email there so you can contact them. And if you're more interested in these kind of things, the arm machine, I did a quite long video explaining how that works in detail. I also did a self-test, so you can see how this ventilates my lungs, and I survived, so it didn't feel that bad. It was an interesting experience. So I will put the link up here or up here. And yeah, thank you for watching. Thank you everybody for supporting me, especially the company, the Schmidbauer Group, for manufacturing all these nice steel parts, and the SICK sensor group, who was able to deliver the pressure sensor in very short notice. Yeah, thank you, stay healthy, and all the best.